Aquamarine. Roman sailors didn't pray before a voyage, they carried aquamarine. The stone was believed to be the solidified essence of seawater, formed in the treasure chests of mermaids at the bottom of the ocean. Throwing a carved aquamarine into a storm was considered the only reliable method of calming the sea. The practice was documented across Greek, Roman, and later medieval maritime cultures spanning over 1,000 years of naval history. Entire fleets carried dedicated quantities of the stone as standard navigational equipment, alongside compasses and charts. Aquamarine is a variety of beryl, the same mineral family as emerald. Its blue-green color comes from iron impurities inside the crystal. Ferrous iron produces blue, ferric iron produces yellow, and the balance between them produces the sea green range the stone is named after. Aqua Marina, water of the sea. The name is a geological accident that turned out to be chemically accurate. The largest aquamarine ever found was unearthed in Brazil in 1910. It weighed 110 kilograms and was the size of a human torso. It was eventually cut into smaller stones, yielding over 200,000 carats of gem material. Brazil remains the dominant source of fine aquamarine today, producing stones from the Minas Gerais region with a clarity and depth of color that no other deposit consistently matches. The stone that sailors trusted with their lives is now the birthstone for March, sold in mall jewelry chains at accessible price points. If you ever go sailing, try carrying one of these. Blue Diamond. Less than 0.1% of all diamonds ever extracted from the earth are blue. Not rare in the way that fine rubies or emeralds are rare in the way that finding one is a geological accident that most mines will never produce in their entire operational lifespan. The Cullinan mine in South Africa is responsible for the majority of the world's supply of blue diamonds, and even there, a significant blue stone is an event, not an expectation. The blue comes from boron, a trace element that has no business being inside a diamond crystal. Diamond forms from carbon under extreme pressure and heat, and the conditions that allow boron to enter that process are so specific and so improbable that geologists still cannot fully predict where or why it happens. Boron absorbs red and yellow light, leaving blue as the dominant visible wavelength. It also does something no other diamond type does. It conducts electricity. Every colorless diamond is an electrical insulator. A blue diamond is a semiconductor. The same stone sitting in a ring is physically and chemically a different class of material than the diamond next to it. In 2016, a 14.62 carat blue diamond called the Oppenheimer Blue sold at Christie's for $57.5 million. That is $3.9 million per carat, the highest price per carat ever recorded at auction for any gemstone at the time. The buyer's name was not disclosed. The stone has not appeared in public since. Paraiba Tourmaline. In 1981, a Brazilian miner named Heitor Dimas Barbosa became convinced there was something extraordinary buried in the hills of Paraíba State in northeastern Brazil. He spent 8 years digging by hand with no geological survey, no institutional backing, and no confirmed evidence of anything below. In 1989, he broke into a pocket of neon blue-green crystals, unlike anything previously documented in gemology. The color was so electrically saturated that gemologists initially questioned whether the stones had been treated, and they had not. The color comes from copper. This is the anomaly. Tourmaline gets its color from a range of trace elements, including iron, manganese, and chromium. Copper-bearing tourmaline had never been documented before Paraíba. Copper produces a blue-green that operates at a completely different level of saturation than iron or manganese can achieve. These stones are so blue that they look like they do not belong in their environment. Gemologists formally categorize this as neon saturation. There is no technical precedent for it in the colored stone market. The original Paraíba deposit in Brazil was effectively mined out within a decade. Similar copper-bearing tourmalines were subsequently found in Nigeria and Mozambique. The market accepted the African stones commercially, but prices for original Brazilian material remained in a separate category entirely. A fine Brazilian Paraíba tourmaline sells for up to $50,000 per carat, making it weight for weight more expensive than the rarest diamonds. The man who dug with his hands for 8 years on a hunch created an entirely new category in the gemological record. Benitoite. Benitoite is the official state gemstone of California. It is also found almost exclusively in one location on Earth, a single hydrothermally altered serpentinite deposit in San Benito County, California, which closed to commercial mining in 2005 and is now operated only as a fee-dig tourist site. The entire commercial supply of benitoite that will ever exist has already been extracted. What is currently in circulation is what there is. The stone was discovered in 1907 and initially misidentified as sapphire. A full chemical analysis revealed it was an entirely new mineral. Its deep blue color comes from the interaction of light with its unusual crystal structure, a ditrigonal dipyramidal form that is extremely rare in nature. That same structure gives benitoite a dispersion rating higher than diamond. Dispersion is the ability to split white light into spectral colors, which creates the fire visible inside a cut stone. Under ultraviolet light, it fluoresces a bright electric blue that is violent in its intensity, one of the strongest fluorescent responses of any known mineral. The stones rarely exceed 2 carats in cut form. Most fine specimens are very small. A clean, well-cut benitoite of 1 carat sells for several $1,000s. There will be no new mining. The deposit is geologically exhausted. The state of California declared a mineral its official gem and then watched the only place it existed close permanently within a century of its discovery. Grandidierite. Grandidierite was named in 1902 by a French mineralogist working in Madagascar. For the following 100 years, it existed almost exclusively as a textbook entry. Facetable, transparent, gem-quality material was so scarce that most gemologists spent entire careers without handling a single cut specimen. It appeared in academic literature as a mineral that technically existed in cuttable form, but practically did not. The stone is trichroic. It displays 3 different colors depending on the viewing axis: blue-green, colorless, and dark greenish-blue. Like other trichroic stones, cutters have to orient each individual crystal under magnification before making a single cut. A miscalculation destroys the optical effect entirely. A significant deposit was found in southern Madagascar around 2014 and briefly introduced faceted stones into the market for the first time. Prices dropped for approximately 2 years. Then the deposit declined and prices recovered. The window closed without announcement. A fine Grandidierite today sells for up to $10,000 per carat. Most people working in the jewelry industry have never seen one. Blue zircon. The oldest material ever dated on the surface of this planet is a zircon crystal from Western Australia, confirmed at 4.4 billion years old. It predates the ocean and the conditions that made life possible. Zircon is not cubic zirconia. This is the single most consequential misunderstanding in the colored stone market. Cubic zirconia is a synthetic material manufactured in a laboratory, invented in 1976. Zircon is a natural mineral that has been forming inside the Earth's crust for over 4 billion years. Blue zircon gets its color through heat treatment applied to brown zircon from Cambodia and Myanmar. The process restructures the crystal at an atomic level, producing a vivid electric blue with a refractive index close to diamond and dispersion that generates intense fire inside a well-cut stone. Decades of confusion with cubic zirconia collapsed the consumer market for natural zircon entirely. A stone scientifically older than almost any object a human being can physically hold is commercially undervalued because it shares 3 letters with a laboratory product. The market has not corrected, and the confusion still persists. Hauyne. Hauyne forms inside volcanic rock. Its blue color comes from sulfur incorporated directly into the crystal structure during formation inside an active volcanic system. The stone is chemically a product of the same geological violence that destroys cities. Gem-quality Hauyne is found in the Eifel volcanic region of Germany and in certain Italian deposits near Rome. The crystals are typically tiny, rarely exceeding a few millimeters, and heavily fractured from the violent conditions of their formation. Finding a crystal large enough and clean enough to cut into even a 1-carat stone is exceptional. The color of fine Hauyne is an ultramarine blue of extreme saturation. It absorbs light rather than scattering it. The visual effect is of depth without reflection, a blue that appears to go inward rather than outward. The Eifel region that produces the best material is not a mine. It is an agricultural and construction excavation zone. The stones are recovered incidentally from road cuts and quarry blasting. Nobody is looking for them specifically. They are found by accident, the same way the volcanoes that made them operated without intention. Larimar. Larimar exists in one place on Earth, a single volcanic deposit in the Dominican Republic, in a mountainous area so remote that the stone was unknown outside the local population until 1974, when a Dominican officer found it on a beach, named it after his daughter and the Spanish word for sea, and filed a mining claim. The deposit had been documented once before, in 1916, when a local priest requested Vatican permission to mine a blue stone he had found in the mountains. The Vatican denied the request. The deposit sat untouched for 58 years. Larimar is a variety of pectolite. It produces blue coloration only in this single deposit through copper substitution in the crystal structure. The patterns inside the stone, white and blue swirling together, replicate the visual texture of shallow Caribbean water seen from above. The resemblance is structural. The surface looks like waves and resembles the sea. Actually, the same copper chemistry that colors the stone also colors the sea it borders. New Age communities in the 1980s called it the Atlantis stone, claiming it was the material described by Plato as native to the lost continent. What that mythology did, regardless of its validity, was generate sustained international demand for a stone with no supply chain beyond artisanal miners working a single mountain. That structure has never formalized. The mountain in Barahora is the only source. When it runs out, there is no other.